Hello guys and welcome back to my YouTube channel. So in this video we are going to be predicting loan eligibility of a customer using machine learning. So the first thing that we are going to take is we are going to import our dependencies. And then we are going to load our loan prediction dataset from memory using the pandas library. So if you have not yet watched my Panda series, I urge you to go back and watch my Panda series so that you do not get lost as we go along the video. So to read our loan prediction data set, we are going to use data frame df is equals to pd.res.csv, and then we are going to provide the path that contains the CSV. So the next thing that we are going to do is we are going to check the shape of our data set using the dot shape object, which is a 614 by 30. And then the next thing that we are going to do is we are going to display the first 5 items in our data set. The first 5 items in our data set, as you can see, we have the loan ID, we have the gender, we have if a person is married, dependents, education, if the person is self-employed, their income, the co-applicant income, loan amount, term, credit, and then property area, and then also the loan status, right? So this is an example of a binary classification problem. So we are going to get the info from our data set. We can see that from loan ID we have 614 none now object, and then also we have married from married we have 611. So this displays each the number of items in each column, right? And then we are going to use the dot describe. The dot describe is going to give us the count, the mean, standard deviation. And then what we are going to do is we are going to set the credit history. As you can see, credit history. We are going to set the data type of this credit history as an object. So to do that, we are going to select the column TF credit history is equals to credit history as type of object. And then we are now going to include as a categorical data. df.describe include O, which is an object. So now, as you can see, we have now included it. So the next thing that we are going to do is we are going to drop the loan ID. So in this case, the loan ID is not useful. The loan ID is only used by banks maybe to identify the applicant form. It's a way of identifying maybe the applicant's form, give it a numbering system, right? So we are just going to drop it from our data set. And then we are going to check if there are any duplicated values. As you can see, we don't have any duplicated values in our columns or in our entire data frame. Now, what we are going to do is we are going to look at the distribution of our data set, right? As we look into the distribution of our data set, we can see that our data set is an imbalanced data set. As you can see, more people were given loans than people that were not given loans. As you can see, Y stands for yes, about 420 or more people were given loans, and then here it's about 200 people were not given loans. And then we are going to use the dot columns object to show the columns in our data set. As you can see, we have the gender, we have married, dependents, education, self-employed, applicant income, co-applicant income, loan amount, term, credit history, property area, and loan status. And then we are going to display the first item in our data set, as you can see now. So now the the next step that we are going to do is we are going to compare our features in our data set with the loan status, right? So the first thing that we are going to do is we are going to create the Facet grid using Seaborn, which is a visualization library that works on top of Matplotlib, right? And then we provide the data set. Uh, the column that you want to plot a Facet grid is the loan status. We use the loan status, right? If it's yes or no. And then we provide the size, which is 3.2, and then the aspect ratio, which is 1.6. The next thing that we are going to do is we are going to compare our loan status with credit history. As you can see, we say grid.map. We are going to map through the credit history, right? So if I run through, you can see that people with a credit history of 1 were more likely to be given a loan, right, than people with a credit history of 0. As you can see that we can see there are about 5 people or 10 people that were given a loan with a credit history of 0. And then the next thing that we are going to see is that some people with a credit history of 1 were not given a loan, and some people with a credit history of 0 were not also given a loan, right? And then the next thing that we are going to do again, we are going to compare the gender, right? We want to see the gender. So we are going to plot the Facet grid for the loan status, and then we are going to use grid.map to look through the gender. So as you can see, more males are more likely to be given a loan than females, right? As you can see here, the graph for the bar chart for males is greater than for females. As you can see also, males are more likely to be declined for a loan than females, right? So the next thing that we are going to check is we are going to compare our loan status with our merit feature, right? So now we are going to use what we call a count plot, right? So if you have not watched, if you are confused about what is a count plot, I urge you to watch my Seaborn tutorial, my introduction to Seaborn tutorial. So it will just pop up on the screen. You can click there and go and watch and come back and watch this video. So we are going to plot a figure of fixed size of 15 by 5. And then we are going to use sns.countplot to then provide the x variable, which is merit. And then we are going to use the loan status as who, and then we are going to provide the data as our data frame, right? So as you can see, um, from our data set, right? As you can see from our data set, that people, as you can see from our data set, that people who are married are most likely to get a loan than people who are not married. As you can see from this, we can see that this graph, people who are married are more likely to get a loan than people who are not married, right? And also, we can also see that the other thing that we can see that people who are married are most likely not to get a loan as compared to people. People who are married are more likely not to get a loan than people who are not married. As you can see, if you compare this with this one, right? And then the other thing that we are going to look through it is the dependence, right? So we are going to use a count plot, and then we provide the x variables dependence compared against the loan status, and then we provide our data frame, right? As you can see, people with zero dependence, right? People with zero dependence are more likely to get a loan. People with zero dependence are more likely to get a loan than those with dependence. As you can see, this one is 1 dependent, and then this one 2 dependents and 3 dependent. And we can also compare this. People with no dependence are more likely also not to get a loan, as you can see with this no, and you compare it to the others, right? And then the next thing that we are going to compare is the level of education, right? If the person is educated, right? So we are going to also use a facet grid, right? So we're going to say grid is equals to sns.facet grid. We are going to provide the data frame. Our column, we are going to use the loan status. The size is going to be a 3 by 2, and then the aspect ratio is going to be a 1 by 6. And then we are going to use the grid.map to map through the sns.countplot, and then we are going to provide the education variable, right? So as you can see, a graduate is more likely to get a loan than a person. A graduate is more likely to get a loan than a person who is not graduated. At the same time, a graduate is more likely to be declined a loan than a person who is not a graduate, right? And then the next feature that we are going to look at is the self-employed, right? If the person is self-employed. So we are going to use the Facet grid again. We'll provide the loan status, and then we are going to look through using the grid.map, sns.countplot, self-employed, right? if the person is self-employed. So we can see that if a person is self-employed, they are more likely not to get a loan. As you can see, if they're self-employed here, they are more likely not to get a loan. And then also you can see that they are more likely to be declined if they are self-employed, right? And then the next thing that we are going to look at is the property area, right? So we are going to use the count plot, SNS.count plot, to provide the property area. We are going to provide the loan status. We are going to compare it against loan status. Our data is we are going to provide our entire data frame, right? As you can see from this, a person from a semi-urban area, they are more likely to get a loan. And then a person from urban areas, again, they are more likely to get a loan. And then a person from a rural area are less likely to get a loan. As you can see, their bar graph is less than any of these two. And you can also see that a person from urban areas and rural areas are more likely to be declined of a loan as compared to a person from uh, the semi-urban areas. So the next thing that we are going to do, we are going to plot a scatter plot of the applicant income and the loan status, right? As you can see, most people that are given loans, their income is more likely to be between 0 and 20,000. As you can see, that's where there is dense. That's where this blue is dense as compared to others. And also, you can also see people from 0 to 20 are also likely to be declined a loan, right? So now, what we are going to do is we are going to look at the numerical data, right? So we are going to use the loan status dot median, and you can see that applicant income, the median is 38,000. And then the other thing that we are going to do is we are going to sort the values, right? We are going to sort the values using df dot sum dot is now. We are going to check if the values is now, and then we are not going to sort them. As you can see, we have now values on credit history. We have 50 now values on credit history, 32 on self-employed, 22 on loan amount, 15 on dependents, 14 on loan amount term. So now the thing that we are going to do is we are going to separate our values into numerical and categorical values. So categorical values are features that show categories, and numerical values are features with numbers. So we are going to say K data is equals to an empty array, num data is equals to an empty area. So we are going to look through for I, C in enumerate. We are going to look through the df d types, which stands for which for looks for the data types in our data frame. If C is equals to an object, we are going to append it to our empty array as categorical data. Else we have numerical data, right? And then what we are going to do is after next, we are going to just transport the categorical data and the numerical data. And let's look at the categorical data. As you can see, we have gender, married, dependence, education, self-employed, credit history, urban, and loan status. And then we are going to look also at the num data with applicants, numerical data with the applicant income, co-applicant income, loan amount term, right? So the next thing that now we are going to do is we are going to say the categorical data is equal to categorical data dot. We are going to use a lambda function to fill in the missing values, right? So we are going to use the lambda function to check if there are any to fill in uh, the missing values, right? And then after that, we are going to check if there are any missing values. As you can see, we don't have any missing values. And then now we are going to our numerical data dot fill and a method is course we are going to use bfill and then in place is equal to true. Then we are going to check if there are any missing data, and you can see we don't have any missing data. The next thing that we are going to do, we are going to use the label encoder, right? to change our categorical features into one word values, right? So the thing is, machine learning algorithms do not understand text; they understand numbers. So if a person is a graduate and not graduate, what we are going to do is that for education, if a person is a graduate, we are going to place 1. If he's not a graduate, we are going to place 0, right? So let's do that, and then let's then transform the target column. Now for the target column, we know that y is equals to 0. Y is equals to 0. That means that if it's yes, we are going to place 0. If it's no, we are going to place 1. And then, okay, let's do it the opposite. If it's yes, we are going to place 1. If it's no, we are going to use 0, right? And then the target, our target is equals to categorical data and then the loan status, right? We are going to use the loan status as our target, variable, as our target feature, right? And then the categorical, we are going in the categorical data frame, we are going to drop the loan status since it is now our target value, right? So now we are going to also transform other values in our data set into one word encoding. And then let's see, as we can see now, if a gender male, maybe it's male, we are going to place it 1. If a person is not married, it's going to be 0. If he's married, it's going to be 1. And then the next thing that we are going to do is we are going to concatenate our categorical features and our numerical features into a single data frame. Since we have transformed both of them, as you can see, now we have both of them. So the next thing that we are going to do, we are going to train our model. So to train our model, what we are going to do is we are going to say our x variable is going to be pd.concat, the categorical data, numerical data, and then along columns. And then our y is going to be the target. So remember I said the target, we already used the target, right? And then the other thing that we are going to use, we are going to use stratified shuttle split to train our model. So if you are not familiar with the stratified shuttle split, I urge you to watch my video on stratified shuttle split. And then the other thing is we are going to be to initialize our models. We have logistic regression, k-nearest neighbor, the support vector classifier, decision tree classifier. We're going to create a dictionary of our models, and then the key for logistic regression, and then the value is the logistic regression object. The same goes for k nearest neighbor. And then the other thing that we are going to do is we are going also need to calculate the precision, recall, F1, loss, accuracy, right? And then what we are going to do now is going to train our train and evaluate our model. For name model in models.items, right? We have this. We are going to loop through the models.items. We are going to print the name of the model. We are going to fit it to our training and test set, going to calculate the loss, and then we are going to finally evaluate the model. And as you can see, we have the logistic regression with the precision of 0.782, 0.797, 0.870. And then we also have k nearest neighbor support vector classifier and the decision tree classifier. So thank you for watching, guys. The first part of our predicting our loan eligibility using machine learning. In the next video, I'm going to be talking about the precision, recall, F1 score, and we are going to look at how we can improve our model training. Thanks for watching, guys. Cheers. I did not want this video to be long.